Okay, so on number 7, 8, 9, 10, we're going to start out with synthetic division because we start out knowing one factor and we're asked to find all the rest. So we're starting out on number 7 with 3x cubed plus 7x squared minus 6x. Okay, and I'm told that x plus 3 is a factor, and I'm supposed to be factoring fully. So I'm going to end up with something that starts with x plus 3 because that's one factor. I know that I'm going to have some other factors here. 1 or 2, something like this. So let's see. I'm going to use synthetic division to figure out what's left when I take out this factor. So that's a negative 3x cubed plus 7x squared minus 6x, and I do have to put 0 for the x to the 0 term. The fact that I don't have a constant term, I have to write 0 for that. Because this is x to the third, x to the second, x to the first, I have to do an x to the 0. Bring this down, and I have 3. Negative 3 times 3 is negative 9. Add. Negative 3 times negative 2 is 6. Add. Negative 3 times 0 is 0. Now, this is important because I was told that this was a factor. If I had gotten a remainder, that would mean they lied to me. Okay? The fact that I'm told this really is a factor means I should get a remainder of 0. So that's good. Now, what this is telling me over here is what's left when I take that factor out. Here's the ones term or the constant term. Here's the x term. Here's the x squared term. So when I factor that out, I'm left with 3x squared minus 2x. Okay, so at this point what I have is x plus 3 is a factor, and when I take it out, I'm left with this. So the next thing I want to do is I want to see if I can factor that. And I can. Okay. It's a pretty basic form of factoring though. What can I do? Take out what? Yeah, just take out the x. I can take out a GCF. So this becomes x times 3x minus 2. So I'm going to actually write that x out in front. I now have 3 factors, x plus 3, just plain x, and 3x minus 2. Notice that I still have 1, 2, 3 x's, and the problem began with x to the third. So I'm fully factored. If they were asking me to solve, I could then go set each one of these equal to 0. But I was just asked to fully factor on this one. Okay? So you did synthetic division to start, and then figured out how you could get the rest of what was left broken apart, usually just by factoring. So this is why we went back over factoring so much. So here we've got 2x third, this is number 8, minus 11x squared plus 5x. And I'm told that x minus 5 is a factor. So I'm going to do synthetic division with 5, 2, negative 11, 5, 0, because I don't have any x to the 0. I don't have a constant term, so I do need to put a 0 for that. Bring this down. And I better get 0 here. I did, so that's good, because otherwise that wouldn't be a factor. So when I factor out, and I'm just rewriting the problem here, what's happening here is if I factor this polynomial, when I factor out x minus 5, what's left is 2x squared minus 1x. This looks a lot like the last one. What can I do to factor that? Take out an x. So I'm going to take that x all the way out front, because we usually like to write that by itself out here. Took out an x, and that left me with 2x minus 1. This is fully factored. You know for sure that it's fully factored if you have no exponents. In other words, if all of your exponents are 1, then there's nothing else to factor. Okay? It can be fully factored with exponents that are 2. Let me give you an example. Let's say you had, I'm just doing it here. let's say you were doing a problem and at the end you got to this point where it was x plus 5 times x squared minus 3. Well, that is fully factored just because this cannot be factored any further. So you know for sure it's fully factored if either you have no exponents that are anything but 1, or if the ones you do have, you can't factor any further. You're sure you can't go any further with them.